In example 3, we want to take a look at factoring a trinomial with a leading coefficient of 1. So we want to make sure we're very clear on that. This process that we're about to talk about only works when that leading term is x squared. We want to look at factoring this expression, which means we want to rewrite it in the form x plus a times x plus b. That is, we want to take this trinomial and rewrite it as the product of two binomials. Obviously, to do this, we need to figure out what those values for a and b should be. And to do that, we'll have to do a little bit of a guessing game. We need to figure out two values, a times b, that multiply together to give us negative 56, which is the last value in the original expression. And we need a plus b in this case to add together to be 1, which is the coefficient of the middle term, or the coefficient of the x term. So again, this is a little bit of a guessing game. We'll probably have to go through some trial and error to think of different numbers that can multiply together to give us negative 56 and add together to give us 1. One obvious pair would be negative 56 and 1. Those would multiply together to give us negative 56, but they would add together to give us negative 5. So in this case, the pair we'd want to go with would be positive 8 and negative 7. These two values multiply together to give us negative 56, and when we add them together, we get positive 1. So we can rewrite this trinomial as x plus 8 times x minus 7. And we can verify that these two expressions are equal by expanding this out. We can take the first term of our first binomial, x, multiplied by the second binomial, and the second term of that first binomial times the second binomial. Then distribute through and simplify to see what we end up with. So we'll end up with x squared minus 7x plus 8x minus 56. And then our two middle terms will combine, since they're like terms, to give us positive 1x, which is exactly the same thing as the original expression. So this process of finding these two values, a and b, is helping us set up something of the form x plus a times x plus b, which will always expand back out, and we can always check our work to verify, will always expand back out to get us to that original expression.